2013, the City of Burnaby commissioned the installation of 8,000 square feet of hot sun solar collectors. This is to heat their 25-meter indoor public swimming pool and preheat the hot waters for the showers at the Bonsor Community Center. This is the largest solar thermal system ever installed in Canada. This is a rough sketch to give you the general idea of the design and layout for this project. The arrows, as illustrated, also show the direction of flow. One of the many benefits to our collectors over our competitors is we build them in place and on site. That way it can be customized to fit and accommodate any roof design or configuration. With these collectors, they can also be built around any kind of roof obstruction. Here are some photos showing the different layout configurations of multiple collector banks on this particular project. A great advantage to our product is you can walk on the fin tubes without causing damage. They also have the ability to freeze solid because they are flexible and can be easily repaired if damage ever did occur.
This is the heat exchanger that heats the hot water from the solar system.
The water is supplied from the sump located in the back, then to the two green pumps, filter, then through these three heat exchangers. Then carries on back up to the roof, through the solar collectors. Now this design was to be set up as two separate solar heaters. The first one being the upper roof with about 2,000 square feet of collector space. From there the water returns through about 900 feet of 2.5-inch pipe. On the lower roof that holds the remaining 6,000 square feet of collectors, the water returns through another additional 600 feet of 2.5-inch pipe. Once the water has made its way all the way along, it goes back down into our mechanical room and into our sump shown here.
So we're using 12-gauge wire to secure the frame to the screen by threading it through the mesh underneath.
As you can see, we are fastening our grid to the mesh. Once complete, we will use the same existing roof gravel on the top of the mesh to act as our ballast for this installation. This method made it possible to install this entire solar panel system without creating one roof penetration.
So that's the 24-volt in to the coil. That's triggered by our controller, or by the hand switch there, one or the other. And there's the three-phase power, 600-volt to the pumps. And extra contacts. Got it. Okay, thanks.
Here we have our solar water internet monitoring programmable control. It is the brain behind the system to ensure the system operates at its maximum efficiency. This controls the pumps, monitors all the various temperature and pressure sensors, and also tracks flow rates. All this data is then collected, runs through a program to calculate the energy savings, and that information is uploaded onto a dedicated website. From the website, we can see and monitor the efficiency and performance of the entire solar heating and cool system. It also shows us the amount of energy produced and money saved each year with the use of solar. The website will also display the full performance and send out real-time notifications if there are any kind of filter or air blockages or any other issue that may arise with the pool.
What's important to understand is that cost-effective, viable solar thermal opportunity comes from the combination of low cost per area and high energy delivery, high efficiency per area. You achieve that with this type of solar collector. The insulation and glazing of our traditional competition is unnecessary when temperatures are low. When you're heating cold water with natural gas, with fossil fuels, that's what doesn't make sense. It makes sense to heat cold water with a low-tech, low-cost, highly efficient solar collector. That's the opportunity.